I'll be walking you guys through a bit of a demo scenario that we actually got from a real life customer environment to show you guys how SEV1 can help you not only detect, diagnose, and defend against DDoS, but also how SEV1 can realistically help you take all that data, compile it in one place, and help you to attack and defend against many other things in your environment. I think it's important for those folks that may not have as much understanding about DDoS, that I give you guys just a really quick background of what DDoS is, and ultimately sort of how we as SEV1 are going to interact with this. So for those of you playing along at home, DDoS is distributed denial of service attacks. And basically the whole point of a DDoS attack is basically to make a network or a machine unavailable using a cyber attack. You hear about all the time in the news. It's a very good way of interrupting and disrupting networks for organizations or governments. And basically, in a nutshell, all it is that you're flooding the system with a bunch of packets from multiple sources, which makes it very difficult to detect, which makes it very difficult to outline, and usually a firewall will not be able to stop these because it is so distributed. So how does SEV1 help? How can we ultimately come in and resolve this for you, or ultimately mitigate this problem? Well, for starters, SEV1 can collect data from everything in your network. So if SEV1's collecting all of your data, we can ultimately give you guys a single place to go to look at your data sets to figure out whether or not I'm being attacked, or ultimately whether I'm having a problem anywhere else. Secondly is intelligent alerting. So because SEV1 is collecting all of this data, what we can do is we can take all of this data, store it, and then ultimately use the historical data that we've collected to allow us to notify you, the end user, that something is different than what we normally see. And we call this deviation from normal. So if we begin to see large spikes in traffic from places that are unusual, or things that we don't normally see, we can proactively notify you of these issues before they actually cause problems. So we're collecting all of your data, we're allowing you to be notified of those issues proactively. And then SEV1 has the ability to collect flow traffic. So now we're not only just collecting metrics, but now we're bringing in that flow traffic that's associated with it. So we're taking the actual packets and associating them with the actual traffic, which gives us a much more granular breakdown of what's going on in the environment and realistically giving us more information about what's going on. So by taking all three of these components, we can ultimately not only let you know that something odd is happening, and then we can investigate it further to sort of figure out what is causing this problem. And that's what we're going to be going through today. So now that I've given you guys some background, I'm going to go ahead and pop into our demo system here. I just want to give you guys some background as to what this demonstration is and sort of why I think it's important that we walk through this. So this demo is actually built off of a real life customer use case that we've come across. This was built off of this use case from a customer, and then we basically took it and recalibrated into our demo system because I do think it is such a valuable piece of information. So we had a customer that did ultimately have a DDoS attack. They were being flooded with these packets, and they really couldn't tell what was going on until they utilized the SEV1 system to really break down what this issue was and walk through the data collection components that we have that ultimately outlined this DDoS attack. So I'm going to walk through the exact steps that this customer did to ultimately get to this point. And what you'll see is that with the collection of data and the functionality of SEV1, how easy it is to ultimately get to the resolution of a problem, which in this case was our DDoS attack. So what I'm going to do is I'm actually going to select this the way the customer had it designed, which was they were only looking at their priority one devices. Now, what's really cool about the way that SEV1 is designed is that SEV1 very easily allows you to organize your data sets. So what I'm about to do is core product out of the box standard functionality. I can take these data sets, group them all together, and then easily access those data sets by simply jumping into a tree here. So in this case here, I'm simply looking for my priority one devices because that's what the customer was looking at. But what you can see is that this dashboard initially showed me every data point for everything in my network. Now, after applying the filter at the upper left-hand corner, you can see that on the fly, I simply selected the data sets that I want for this demonstration. So one of the huge things that SEV1 provides to users is the fact that we can isolate data sets on the fly without having to actually build out custom specific reports. So now I've taken that large overhanging report and filtered it down specifically to a priority one device group. And as I mentioned, this is really great to users. It means I don't have to waste time building hundreds of reports. I can build one really good report and then access those data sets accordingly. Now, this page we're looking at is showing me all of the active alerts and alarms that I have in my environment today. So what you'll notice is that by default, it's showing me all of the alarms and alerts that I have for my priority one devices in my SEV1 environment. We can see the criticality broken down at the top here. I can see them broken out by each individual device. And then I can actually see the alarm itself as it exists in the alerts table below. These alert policies, many of them are out of the box. Others were created specifically by the end user. But what's really cool about this is that I immediately can look at this report and understand which ones are critical and which ones are not so critical based on the hierarchy of these alerts. And in our use case here, what we noticed was that we were actually having an issue with our firewall here, our Chicago firewall. And you can see that it is an alert. And if I hover over this, the issue that we had was that we had a huge drop in connections. So this all spawned from the fact that there was a huge drop in VPN connections. And this is what alarm does to this issue. Users were immediately being dropped off their VPN, and we had a huge decline in VPN utilization. And that's really what brought this problem forward. So when this came forward, and since VPNs are very public facing and this was easily detectable, we went ahead and we're going to drill down into this device and specifically find out why we had a drop in connections. So this user went, okay, I saw that I had an issue with my VPN. What I need is more information about what the heck is going on here. And what you notice is that we have a bunch of words here that are highlighted blue. When you see words highlighted blue in SEV1, what that means is that there's more information available about this device and this individual data set. So at the time, the user wanted more information. So what he decided to do was click on the Chicago firewall. And ultimately, SEV1 was smart enough to know that there are two reports that can provide me more information about this firewall: the network device summary and our Cisco ASA device summary. Well, since this is specifically an ASA device, and since it is more security oriented of a problem, he decided he wanted to drill down into the Cisco ASA device report. And what I've just done is actually a hugely valuable function of the SEV1 product. And what this is the ability for users to drill down from one report into another report and provide me information about what was clicked on. So imagine in a troubleshooting scenario, you have a problem. Instead of me having to find the report that that device is a part of and accessing that data set, I can simply just click. And what it does is it automatically takes the information from the previous report, which is our network performance summary report, and then copies it over into our Cisco ASA device summary report, in which case I am now getting specific information for this specific device. So you can see how in this scenario or in any other troubleshooting scenario, the ability for me to simply click and pass data will save me not only valuable time, but it also provides me more direct context as to what we're looking at. So this report is specific to the Chicago firewall. You'll notice that I have a bunch of great information about this firewall: reachability, connections, tunnels, SSL, all kinds of great stuff. And as we can see here, there are also tabs at the top of this page. And each one of these tabs now corresponds specifically to this firewall. What you see in front of you is what we call a template. These templates are a part of SEV1 and they are designed to be blank by default. They are passed information from other reports and the data is automatically filled into them. So again, the value behind this is that this report can be used for any device that is a Cisco ASA device. And I don't even have to know this beforehand. I can simply click and pass the data forward. So in the use case that we're actually following here, this user drilled down, and what you can see is that we have a bunch of good information: reachability, SSL, as I mentioned. And what you'll notice is that that same alarm and alert that we saw on the previous page also appears in this page here. This alarm is specific to connections. So what we want to do is then go to the next tab here and look at the actual current connections that we have for this firewall. Now, what we can see here is that if we take a look at this report, we can see that we had two drops in connections. And if we looked at that alarm, when I apologize, I didn't grab the time, but that alarm corresponds to this decrease in availability. So you'll notice that if I hover over this report here, that we had a drop in connections at 4:30 in the morning Eastern time from our previous point at 48 down to 0. So we can see that this time period, roughly between 4 and 4:30, we had a drop in connections. So we can see that this alarm does correspond to the decrease in connections. So we can see that the alarm is valuable. We can see the alarm is good. So now really what we need more information on is to sort of try and figure out why we had this drop in connections, obviously. So what we're going to do is we're going to jump through here and see if these data sets provide us any context. Now, for the most part, I'm not really interested in RAS or IPsec in this case. IPsec might tell me if we have any traffic passing through here. Obviously, if there was no traffic or there was also a drop in traffic, that would potentially mirror the drop in connections that we have. But you can see here that we had plenty of traffic passing through here. There was not that dip at 4:30 when we had that drop in connections. SSL would be whether or not we can do connection type things. Let's take a look here, but something tells me we have no issues here. Yep, our SSLs are operating, and that if we take a look at the PM, the performance metric here, no issues in terms of SSL active connections. So the next item we look at will be our CPU. Now we're getting more into the actual core components of the device itself. And the first thing that I notice is that we have huge spikes in CPU, and they look like they correlate to when we had those drops in connections. But again, correlation does not equal causation. So let's actually take a look at this large spike here. And if I hover over this, you will notice that the huge increase in CPU we have matches up with that drop in connections that we had. So the fact that we've had a huge increase in CPU and a massive drop in connections at the same time seems almost too coinkydink, as they say, to match up. So what we're going to actually do here is see if we can correlate this increase in CPU, since it is so specific to the drop in connections, with that connection drop. And what I'm going to actually do is click on this report. So another really cool function of SEV1 is that really from any report, I can access more data about what I need. So in this case here, I want to take the data from my CPU in this report, pass this information into another template where I am now analyzing the increase in CPU. And what I will do is ultimately overlay that drop in connections. So you can see that we're 3 reports deep here. We started our net performance report. We moved into a report that was specific to the Cisco ASA device. And now I'm in what we call an instant graph workspace that allows me to sort of play around here and access data sets that might not be the same. So what I want to do is I'm going to jump in here and I'm going to take the connections and overlay our connections on top of our CPU so that I can 100% correlate that this drop in connections matches up with this increase in CPU. So what I've actually done is I've taken 2 data sets that are not connected, and now I'm interconnecting them on a single report with 1 click. And you can see that if we look at this report here, it is exact. When there is a huge increase in CPU, there was that same exact drop in connections. So this is enough for me to believe that when we had that spike in CPU, that we also had that massive drop in connections. These 2 items have to be correlated. So now that we've lined these up and confirmed that these are actually correlated, we're going to drop back into our Cisco ASA report here, simply by clicking on the little breadcrumb here, taking me back to the previous report. And now I need to figure out what could possibly cause that huge increase in CPU. And the very first thing most of us think of is processes. Obviously, something is eating up my CPU. Let's figure out what that is. And again, there's all these tabs at the top here. I have plenty of information available to me based on this report that was provided. So the end user at this point decided that, okay, I know I had a drop in connections. I know I had a huge increase in CPU. Let's see if we can determine what process ate up all of my CPU. So if we look at this report here, what you'll notice is that the first thing I see on the right-hand side is that we again see 2 massive spikes on this chart. We need to figure out what's causing these massive spikes. So in my case, it seems easy enough for us to simply just click this button here and sort this by maximum to see what actually is causing this increase. So one of the things that's really unique about the way that SEV1 works is that we as SEV1 provide users all kinds of ways to visualize their data sets. So you'll notice on the left-hand side, we have a very concise chart that's providing us whole numbers, or excuse me, not whole numbers, providing us single numbers for massive things. If you notice in the upper right-hand corner here, this is a 48-hour period. We're looking at this data over 48 hours. So what this report on the left-hand side is doing is it's actually taking the data and giving me one value for the past 48 hours. We call these top-end reports. I like to equate them to David Letterman's top 10 list. This is always going to show me the top 10 of a certain category. And in this case, it is CPU for processes. On the right-hand side, you'll see that this report is specifically connected to this top end report. This report shows me every poll period that comprise this 48-hour period. So as I scroll over here, I'm getting exact poll points that comprise these 48-hour averages. These data sets are connected. So if we look at this chart on the left-hand side here, you'll notice that we did have one process that hugely spiked during this period of time. So what I want to see is whether or not this process matches these spikes. And the easiest way to do that is to simply unselect, and then I'm just going to select that one process. And what you'll see is that all of these reports all fall in line. They match up with the single process that I select on the left-hand side. So in this case here, if we look at this report, you can see that we had huge spikes in processes for SSL for CPU, and shocker, it matches up exactly with the spike in CPU that we saw and the drop in connections. So it's fair to say, even though we looked at SSL and we saw that SSL was operating at a reasonable pace, we did have spikes in this SSL processee that caused a huge increase in CPU. So by collecting all of this data and allowing us to organize this data in many different ways, even when reports that are average might lie to us, when we start looking at the raw data, we're always able to see what's going on in an individual's aspect here. So what we can see here is that clearly the SSL processee is causing that increase in CPU, and we've already determined that increase in CPU is causing that drop in connections. So what I need to do is sort of get more information about this increase in processing. And the way I'm going to do that is like what we did similar. I'm going to go ahead and I'm going to drill down into my data analysis workspace here. I'm going to get more information about this individual process for CPU overtime. And this is really where you're going to start to see the power of the SevOne data platform. And this is really where we start to see how collecting historical data can help you be proactive and how it can ultimately help you in determining whether or not data sets are normal. So if you look at this report here, first thing you'll notice, at least the first thing that was noticed by our end user, is that there's three different color coding and shading on this report. You'll see that we have the solid blue line, we have the dashed blue line, and then we have the blue shading. So let's start with the solid blue line. The solid blue line is the data set that we actually saw during this 48-hour period. You will see that there are these large spikes that were collected for the CPU time during this period of time. Then you'll see that there is these dashed lines. These dashed lines are the baseline. So for every data set that SevOne collects, we always create a baseline, roughly a 10-week rolling average of what is normal for that data set that's collected for that specific period of time. So our baseline tool is unique in the sense that it is not, I usually see 45. It's, I usually see 45 at 8:35 on Tuesday. So I can use the SevOne baseline tool to understand what I should be seeing and compare it to the data set that I am actively seeing. So by having a baseline and having a standard of what I expect to see, I can use this to help me understand whether or not what I've collected is normal. And that's what we're trying to find out here in this scenario, is whether or not this large increase in the SSL process is normal. Because if this is something that normally happens, well, then it's not fair for us to say that this increase is what's causing this problem. Maybe this happens every day. Maybe this is just the backup that we're performing. So what we need to find out is whether or not this is normal. And the way that we can do that is by overlaying the exact data sets we have with the current data sets we have. And if you see, if I hover over this, you'll notice that normally for this data point, I usually see roughly 25% CPU time. Right now, I'm seeing way above 100 for this CPU time. So this is clearly not normal. This is not something that we normally see, and it's fair to say that this is something that we need to investigate because it is abnormal. The other thing that's really cool that SevOne can do is we can overlay a standard deviation, an acceptable difference from normal that we're comfortable with. And this blue shading is really a huge component of the product. This allows us to build alert policies based off the baseline. So inside Sev1, what you can do is you can build an alert policy that says, okay, you know what is normal. I want you to only alert on data sets that exceed normal by a certain percentage, or by a certain standard deviation, or by a certain delta, so that I don't have to build an alert policy for every single device, nor do I have to build a static alert policy that says if I go above 40, I want to be notified. We can build an alert policy that simply says, okay, all server devices, all network devices, if you begin to see CPU go above normal by one standard deviation, which is roughly 66.5%, I want to be notified. Think how powerful it could be building a single alert policy that automatically notifies you of when things deviate from normal. And that's what's possible with inside Sev1. And that's ultimately what triggered this alarm in this use case for this customer, is they had built a policy that said, okay, I just want to be notified if my connections drop below what is normal. And that's what happened. And that's how we got down this path. So by having this baseline, which is automatically generated for every data set, and by being able to alert on that and visualize that, you can take these data sets and ultimately use them to help you catch problems and ultimately help you resolve issues and hopefully be proactive enough to be able to resolve them before they actually affect end users. But just wanted to highlight that simply because it is a huge component of the Sev1 product. And then we can also compare our data sets over time. So this is what we call time over time, where you have the ability to actually calculate that over time, and we can project them into the future. So Sev1 has the ability to take our data sets and ultimately project forward. Now, those were not part of the use case. I just like to outline them since we are in this location. So Sev1 has the ability to collect the data and ultimately tell you whether or not that data is normal or not. So basically what we've determined here is that this is not normal, that we have a huge increase in CPU and we have a huge drop in connections, and that the SSL processing is the culprit of this. So now, since this is SSL, one of the things that we're going to check is our flow statistics. Because one of the reasons why SSL might be using a lot of process time is something that potentially could be observable in our flow statistics. And this goes back to one of the many things that Sev1 does well that allows you to integrate your actual metric data with the flow data that's coming in from these devices. So we are collecting metrics from this firewall, but we are also collecting flow traffic from this firewall. And the cool thing is that we can access those data sets in the same location, even though they are two very different data sets. So by being able to take this flow data and being able to integrate it in with our metrics, what you'll notice is that I can see on the left-hand side here the actual traffic that's passing through the interfaces on the firewalls. And then, unfortunately, I kept the time span at 48 hours. So this is quite a bit of flow traffic that I'm pulling out. But what we'll be able to see is that we'll be able to see exactly what is passing over these interfaces during this 48-hour period. So what's cool is that now I can see on the left-hand side, okay, these are my most utilized interfaces. They're broken down by interface name, actual indicator, and the amount of traffic that's passing through. Then on the right-hand side, I can see who my top talkers are, which IP addresses, what applications are communicating the most with this traffic that's passing through. Then if we continue to go down here, we can actually see next hops. So if I expand this report out, and if I do this, it's probably going to have to reload, but I think this is really an awesome use case that we have. We can actually show you the top conversations that are passing over these interfaces. So if you look at this report here, I can actually functionally follow this all the way through from my application IP to my application direction, to the client, to the next hop, to the protocol. I can follow this all the way through and see exactly what traffic is passing through each one of these. So our flow capabilities, though robust and broad, can actually be visualized in a way that greatly increase the value. Because by having not only the metric data that's in here, I can help visualize the actual flow traffic that's being pulled through here. And realistically, by having your flow and your metrics in one place, what we can do is give you guys, in a troubleshooting scenario like we have now, the functionality to actually flip from my metrics into my flow data in the single report. So I know a lot of customers or a lot of tools have a flow tool and a metric tool. I can take these data sets and I can actually overlay them in a single report here so I can see what applications are being affected by my flow. And then realistically, using something like the Sankey diagram here, I can actually show you the actual pattern at which the flow is progressing. But one of the things that we always keep a report for in our firewalls is a DDoS actual flow report. And this is definitely something that we hard code in just internally that we actually gave to the customer. So these reports are great in the sense that we can share these with customers. So we actually share this with a customer. And what we did was we provided them our best firewall report, which is really what this is. And what we do is we always provide a DDoS flow report in our firewall reports. And in this case, it actually proved valuable because when we looked at the flow, what we noticed is that if we specifically looked at this DDoS report, you'll notice that there is a large increase in these TCP SYN packets. And for those of you that aren't familiar with DDoS, this is one of the clear indicators of a DDoS attack. And this is a flow report that's provided that we can provide to customers that allows us to sniff out these things. Because basically, SYN flow is somebody exploiting a handshake with a TCP connection. And this packet type, this TCP SYN packet type, will be visible in your flow traffic. So if we are building flow reports that are specifically looking for these things, we can actually help customers look at our flow traffic and understand whether or not there are these SYN packets in our flow records that are coming in. And if you look at this report, you'll see that we have two huge increases in these SYN packets. And if I hover over this flow report here, what you'll notice is that it matches up exactly with the drop in connections, the huge increase in CPU, and the huge increase in SSL use for the processing of CPU. So by actually collecting all these data points, what we've done here is sort of done a networking version of Hansel and Gretel. We have followed all of these breadcrumbs through. We had an alert around connections. That alert around connections took me to CPU. That then took me to, that alert took me to connections. That alert with connections then took me to CPU. CPU then took me to a process, SSL. Then SSL took me to flow. So now I'm following these breadcrumbs down and analyzing these parts of my infrastructure that are now leading me to believe that I have had a DDoS attack. And what I can do is take these data sets and actually provide them to a security team and evaluate this. But again, correlation does not equal causation. I want to 100% confirm that this flow traffic, this huge increase in SYN packets, is actually matching up with my connections. And I can easily do that using a component of the SEV1 product that we are particularly fond of, which is what we like to call metric to flow. So SEV1 doesn't just allow you to keep flow data in reports with metric data. We actually allow you to stitch it together so that when I'm looking at a report for data and I want more information about the flow, I can actually get it on demand on the fly. And the way you do that is by clicking this little plus button here, and you'll notice that, it's providing me a bunch of additional fields that I can provide for this report. In our case, I want flow. I want to see the flow traffic that is passing over this particular VPN connections. So I can see whether or not there is a huge increase in these SYN packets when we have this drop in connections. And now what I did is I pulled the flow traffic from the report. And what we can actually see as I zoom out on this report here is that when we have this drop in connections, we have a spike in these SYN packets. So I can 100% correlate that when I have a drop in connections, I have a huge spike in these SYN packets that match the connection drop. So what I've done is I've taken several different types of data and gone ahead and gone, all right, well, this drop in connections looks bad. How do I find out what's causing this? And we can actually go through the system by taking all of the data sets we've collected, integrate them all together, and ultimately correlate them to this DDoS attack. So Sev1 can take a whole bunch of data, put it in one single place for you guys to access, and then realistically allow you to definitively look at a report and go, yes, drop in connections equals spike in these SYN packets, which is a key indicator of a DDoS attack. I can take this information. I have the source IP for this flow. I can take this source IP. I can shovel it off to my security team and go, hey, this is a DDoS attack. Sev1 helped me prove it. I want you to take these IP addresses and block them on the firewall. So this correlation and this data collection and this report in general can take something small like a connections alert and ultimately lead me to a DDoS attack. And that really is the power that the Sev1 data platform allows you guys to have. So this customer actually brought this to our attention. We were particularly glad we were able to help them with this problem. And realistically, they blocked those IP addresses and they had that they removed that DDoS attack from their system. So this is a real life use case that you guys could utilize today using the Sev1 tool. And you definitely could use this to not only just monitor your network in general. I've shown you some of the great things we can do, but ultimately when it comes to DDoS monitoring, Sev1 can get you that information from the flow packets and correlate them to the data sets as well. No, I just want to say I really appreciate you folks joining me this afternoon and learning more about Sev1. I really hope that you folks ask for more information. I'd love to provide it to you guys. And I hope this was informational. There'll be many more of these to come. Myself and Haley and the rest of the Sev1 team really appreciate you joining us today.